So today we are continuing these word problems. We are doing the last type. These are distance or motion problems. So our strategy is going to be very similar to how we did the mixture problems yesterday. I have a little more information going on in some of these, so I will still recommend setting up with a table. Looking at this one, Russ and Janet are running in the Strawberry Hill Fun Run. Russ runs at 7 miles per hour, Janet at 5 miles per hour. If they start at the same time, how long will it be before they are 1.5 miles apart? Alright, so my information here. I'm not mixing things together, but I do have two people we can organize, Russ and Janet. I need a different formula across the top. Remember, distance is equal to rate times time. So I'm going to do R times T equals D. So there's my formula. Let's start filling in the blanks. Russ is running 7 miles per hour, so that is his rate. Janet is 5 miles per hour, so her rate is 5. They started at the same time, so I don't know how long they've been running, but I know it's the same for both of them, so I'm going to put X on both of those. So my distance, we have 7x and we have a 5x. The equation on these you have to think a little more about. We have to be able to think of the scenario. If they are running a race, they're starting from the same point. So we know that Russ runs a distance of 7x. They're running a race, so they're going the same direction. Janet's coming up behind. She hasn't ran as far, so she's only a 5x. So their distance apart is just from here to here. There are a couple ways for how you might set this up, but what I'm going to do is subtract. If I want to find out how far apart they are, since they were going the same direction, I can take how far he traveled minus how far she traveled, and I get their total distance apart of 1.5. So now, solving our equation, we have 2x equals 1.5. Divide by your 2, and x is 0.75. So answering the question, they started at the same time, so we want to know how long it will be. So it will take 0.75 hours, or 3/4 of an hour. That's the same as 45 minutes. If you prefer to answer that way, I would accept either one. As you're watching this video, if you have any questions, please feel free to pause it, raise your hand, and I'm happy to come over and answer whatever questions you have. Okay, let's take a look at another one. So Bill left his house at 2 p.m. and rode his bicycle down Main Street at a speed of 12 miles per hour. When his friend Mary arrived at his house at 2:10 p.m., Bill's mother told her the direction in which Bill went, and Mary cycled after him at a speed of 16 miles per hour. At what time did Mary catch up with Bill? So we're still talking about this distance. We have our people here, Bill and Mary. Put your formula across the top. Rate times time equals distance. Okay, so we know that Bill rode 12 miles per hour, so that's his rate. We know Mary rode 16 miles per hour, so that's her rate. Our time we have to be a little more careful with. You have to pick one of these to be x. This is why it's so important to define your variables, because we could do this different depending on if we make Bill x or Mary x. So I'll just go ahead and say Bill is my x. That's his time. Now Mary started later than him, so her time would be the same as his minus she came late. Now if you look, he started at 2 and she started at 2:10. You have to be very careful though. People look at this and they want to say x minus 10 because it was 10 minutes difference. Our rate is miles per hour. That means this time has to be in hours. Your units have to match. So if your rate's miles per hour, your time has to be hours. That means my 10 minutes, I have to convert that into hours. We know there are 60 minutes in an hour, so just divide it by 60, so that's 1/6 of an hour. So Mary's time is actually x minus 1/6. Okay, distance, multiply. So Bill would be 12x, Mary is 16 times x minus 1/6. Alright, this time, think about your scenario. We have Bill here riding. Mary, she started later, but she's catching up to him. So that means their distances have to be the same. They started at the same house, they ended at the same place. So our equation this time, we just set the two equal. Bill's distance has to equal Mary's distance. Okay, distribute. If I subtract my 16x over, divide by -4, and we get 2/3. So I want to know what time Mary caught up with him. This is 2/3 of an hour. Okay, that's my x. X in our scenario was how long Bill had been riding. So if he's been riding 2/3 of an hour, in terms of minutes, if you take that times 60, that's 40 minutes. He started at 2 and he rode for 40 minutes, so Mary met Bill at 2:40 p.m. So you have to be careful on this one, defining your variable and answering the question, and watch your units. There were a couple tricks there. Okay. Again, if you have questions, pause the video, raise your hand. I'm happy to come answer them. One more example for today. Joanne took 20 minutes to drive her boat upstream to water ski at her favorite spot. Coming back later in the day at the same boat speed took her 15 minutes. If the current in that part of the river is 5 kilometers per hour, what was her boat speed? So this is still a distance problem. Rate times time equals distance. She went somewhere and she came back. Okay. I know it took 20 minutes to go upstream, so going there took 20. But again, you have to be careful. I can't put a 20 here because my rate is in kilometers per hour, so time has to be in hours. So if you want to change 20 into hours, 20 over 60, that's 1/3. So 1/3 of an hour going there. Coming back was 15 minutes. So 15 out of 60 is 1/4. Okay, we are trying to find her boat speed. Going there, it took her longer. What happened is she was trying to go. She had her boat set at some speed, let's call it X. And the current of the river was pushing back. We know that the river is going at 5. And so what it ended up doing is slowing her down. So her overall speed was just X minus the current, so X minus 5. Coming back, now she's coming back at a speed of X, and the river is still there at a speed of 5, but it's pushing her along, so it actually speeds her up. So coming back, her speed is X plus 5. So distance, we multiply. If you go somewhere and come back, it was the same distance both ways, so this time we are again going to set those equal. So distribute 1/3 X minus 5/3 equals 1/4 X plus 5/4. If I subtract over my 1/4, that's 1/12 X. Add over my 5/3. And remember, if you don't have your own calculator, you're welcome to use the one on your Chromebook here. When you add these, if you do use the calculator, you get a decimal. I want an exact answer, so don't round a decimal within the problem, just keep it as a fraction. So that's 35/12. So if I multiply by 12 on each side, I get X equals 35. So the question was, what was her boat speed? And that was what our X represented. So the boat speed was 35 kilometers per hour. Okay. So that is the end of the notes for this section. What I would like for you to do is add your homework onto the homework from yesterday. So we are going to do page 99, 20, 22, 24, and 28. So that means tomorrow you should have a total of 8 problems ready to turn in to me.